Welcome to this tutorial on building a blockchain-based inventory management system. In the era of digital transformation, integrating blockchain technology can significantly improve transparency and traceability in inventory management. Today, we will create a simple blockchain system that enables us to manage inventory efficiently and securely. To kick things off, let's briefly discuss what blockchain is and how it applies to inventory management. A blockchain is a distributed ledger technology where transactions are recorded across multiple computers. This decentralization ensures that the data is tamper-proof, secure, and visible to all parties. In an inventory management context, this can help track items from manufacturer to consumer, seamlessly auditing changes and allowing easy access to all relevant parties. Before we dive into the code, let's set up our development environment. We will be using Java, a powerful and versatile language for building our inventory management system. Make sure you have JDK installed on your machine. If you haven't installed it yet, please check the official Oracle website for instructions. You will also need an IDE. I recommend using IntelliJ IDEA for this project. It supports Java out of the box and has many helpful features. Make sure you have it set up before we continue. Now, let's create a new Java project in IntelliJ. Open IntelliJ IDEA and click on Create New Project. Select Java. Ensure the SDK is set to JDK 11 or above and click Next. Name your project Blockchain Inventory System and click Finish. In this project, we'll create several classes to represent our blockchain and inventory items. The first class we'll create is Block. This class will represent each block in the blockchain. The block class has a constructor for creating new blocks with a reference to the previous block's hash, the data it holds, and a timestamp. Next, let's implement the calculateHash method using SHA-256 hashing. Now that we have the block class, let's create another class called Blockchain to manage our collection of blocks. This class will handle adding blocks, as well as maintaining the chain integrity. The blockchain class initializes with a list of blocks and creates the Genesis block, which is the first block in the chain. Next, we have the addBlock method, which creates and adds a new block using the data passed into it. Next, we will implement an inventory item class that represents the items we are managing. This will have attributes such as name, quantity, and maybe a price, along with a method to represent the item as a block-compatible string. Now that we have the inventory item class designed, we can integrate it into our blockchain. This allows us to store details about each inventory item as it gets added to the blockchain. Next, let's modify our addBlock method in the blockchain class to accept inventory item objects instead of plain string data. This will give us a more structured way of managing our inventory. To finalize our inventory management system, let's create a main class to demonstrate its functionality. This class will allow us to create a blockchain and add inventory items to it. In the main method, we create an instance of our blockchain, add a couple of inventory items, and then print out the blocks in the blockchain. This gives us a clear picture of our inventory and its history. As a quick test, let's add some more items and inspect the blockchain again. This will allow us to see the dynamic nature of our inventory system, incrementing with each new item added while ensuring integrity. Now, you can run this updated main class and observe how the blockchain updates with each new item. Each block represents an inventory item transaction, giving us total transparency for auditing purposes. Now, let's implement a function to verify the integrity of our blockchain. One key feature of blockchain is ensuring that all blocks remain unaltered. We will write a method to check the validity of our chain. This is chainValid method iterates through the blockchain and checks whether the hashes match and if the previous block's hash matches with the current block's previous hash. This double-checks the integrity of our data. Let's create a small demonstration in our main class to test this new feature. We'll add a validity check after the inventory items have been added. Save the changes and run the main method again. You should see a confirmation message stating that our blockchain is indeed valid. If we were to alter a field in any of our blocks, it would instantly result in an invalid chain verification when rechecked. Now, let's summarize what we've achieved in this tutorial. We successfully built a simple blockchain-based inventory management system using Java. We went through the process of creating blocks, managing a blockchain, and validating its integrity. To further extend this application, Consider adding features like user authentication, a user interface, network nodes for distributed ledger capabilities, or even integrating smart contracts for automated inventory transactions. Thank you for watching our tutorial on building a blockchain-based inventory management system. If you found this helpful, please like and subscribe for more content on Java programming and emerging technologies. Leave your comments and questions below, and I will see you in the next video.